I want to introduce you to Dan Erez. He's going to represent serverless and databases. He's a software architect and a tech lead. He has worked in enterprises and startups. Currently, he's focusing his work on cloud modernization as well as DevOps innovations. Additionally, he writes his own blogs and attends conferences such as this one. Yeah, he will review your best options along with code examples. So please welcome him.
Thank you, that was great. Good morning, everyone. Thanks for coming. It's so exciting to be here. My first time at HipCon and in Serbia. And meanwhile, everything is great. And I'm going to talk today about the love and hate relationship between serverless and databases. And first, I'll start by putting us all on the same page regarding serverless and make you think like me it's a great option in many cases. And then talk a little bit about database complexities that can come with it, especially in relational connection-based databases. And then we can see what are the possible options for you to deal with these complexities. Well, I was introduced, so I'll skip this one and start by reminding us all why serverless is great. Right? We have many reasons, both in the operational and in the development side. First of all, you don't have any servers, right? Of course, there are servers in the back end, but usually you don't maintain them. Although you can, and maybe it's even cheaper to run serverless on-prem using Knative or another framework. But even if it's on a public cloud, you don't have to worry about it. And it's not just operational. You as developers have the ability to quickly send your code to production without begging for new servers and worry about maintenance and other stuff along the way. And it can be a big advantage. Not everyone is working in a few people startup that everything moves quickly there. I've worked at big companies that processes were very slow, especially when you're deploying a new application or a new service. So it's one advantage. The cost. Right, it's the comment says that when you're small, it's better to go to the cloud because it's cheaper. But once you grow big, you start paying a lot of money to the cloud provider, and this is one way to save money on the right use cases, of course. But actually, it should be the logical option for every service. Why pay for some things that we don't use, right? So this is exactly what they do in serverless, and you can start for free. You have like 1 million invocations in AWS and in Google and in Azure. So it's enough to do a POC or even start a new project or a company, and your compute is free. It's a big advantage, so you can move fast, and it's easier to convince your manager, if you've been in the previous talk, how to convince your managers about refactoring. So here is a big plus. Right? It's easier to confirm to something that is free. So that's another one. And scalability. You don't have to worry about adding more servers, managing them. It's true that you can use Kubernetes for that, but Kubernetes is much more complicated. Here, you basically do nothing. And in Kubernetes, you will pay even if you don't have any workloads, which is not the case in serverless. So we have advantages versus Kubernetes as well. And a nice advantage for developers especially is that it forces you to think about the architecture in a better way, right? Because serverless functions are more event-driven oriented. They should be triggered somehow, do the work in a quick manner because you pay for the runtime as well, and pass the result on to another queue or to a database or to another function. So it forces you to think differently in a more correct way. Usually event-driven and decoupling of the modules in the application is a good idea for almost any application. Well, just to be fair, I want to say that there are few downsides as well, right? Nothing is perfect, and you always have to consider the pros and cons for everything. If you were working in an existing, on an existing application, and this is the case for, I think, most people, it is more rare to start something from scratch and do all the right choices from the beginning. Usually you come to an existing application if you're joining a company that's been around for a few years. It's not as easy as wrapping it all in a Docker container and putting it in the cloud, right? You have to do some migration, some refactoring, some breaking of the code. Remember that serverless function should be small and fast and stateless. So this can be an issue. Again, pointing back to the previous session, refactoring is not always accepted with a smile, but you can do it easily, gradually. You can just take the new functionality and put it on serverless. So you have your option, but you have to consider that all or nothing is usually not the best option. Some patterns in serverless might be costly. It's true that anyhow you pay for not maintaining the servers and buying them and all the stuff around operations, but if your runtime is long, you're going to start paying. The calculation for the cost is not just the number of invocations, but also some combination of the runtime and the memory you use. So you have to think about that. Not everything is suitable for serverless. And at the end, if you build a big application and ends up with tons of functions, you have to manage it somehow, right? Versioning, using some common infrastructure, everything else that's related to managing a lot of function. So few drawbacks, but still a great idea. Well, that was a bit about serverless. Now, what about databases? Even if you have this amazing architecture with lots of serverless functions and microservices and queues and message brokers in the middle, at the end, you probably want to use some kind of data store, right? Some kind of database. And in many cases, it will be a relational database that uses connection, right? So what? What's the problem with connection? Well, I start by saying that the connection itself is a problem, right? Today, we expect to send our commands or queries directly, like we do in REST, to REST endpoints or GraphQL. But remember that databases have been around for a long time, and it's this concept of connection base is kind of a legacy that came to us with older databases. Oracle, for example, which is still being used by many companies. Anyone here is working in a company that uses Oracle still? Yeah, a few. It's less on the newer startups, but more on legacy, banks, government. It was built, I think it was first released in 1979, right? It's 45 years ago. So we have some history, and this is one of the results. And the problem is that establishing a connection can be time-consuming. It can take 100 milliseconds, 200 milliseconds, even more. And this is just forming a connection, right? Without all the queries and inserts that come along with it. That's why usually you work with some connection pools, but with serverless, it might be a problem. And the last thing is the capacity. In Postgres, for example, I think the default number of connection is 100, and in MySQL it's 150 or 151. So these numbers are looking funny in a million user environment, right? In many cases, it is not enough, and we have to increase this number. But then we have to ask ourselves whether the database machine can handle so much action, right? And start solving that as well. So basically what we have here is a collision between two concepts, right? Serverless is quick to start, and connection establishment take time, and serverless should be short-lived, whether database connection should be pulled and not be restarted all the time. The scaling is different. So we have things to consider here and resolve it somehow, right? Because we do want to use databases at the end, probably, not for our application, but it's a common use case. So what can we do? And the good news is there's a lot of stuff we can do, and I'll overview many of the options. And we'll start from the beginning. We'll start from the simple solution. My man Prince here did not invent the KISS principle, but he definitely wrote a song about it. I hope you know it. And who actually invented this principle was the US Navy in 1960. So it's been around for a while, and now we know it as keep it simple, stupid, right? But it was also acronym for keep it super simple, or keep it simple and standard, or short and sweet. So pick your own, but the idea is clear. Start from the simplest solutions. So we start simple. First of all, once we acknowledge that there might be a problem, we have to ask ourselves whether we can deal with this problem in a configuration kind of way. For example, maybe if we just increase the number of database connections, this would be enough. Not all systems are addressing millions of users, right? It might be an internal system with a few hundred users, so maybe increasing it from 100 to 500 should do the work. Of course, you should always monitor stuff and decide whether this solution is still valid, but this can be one option. If that's not enough, you can work on the other side and limit the number of concurrent function invocations, right? So some cloud providers can promise you concurrency of thousands, maybe tens of thousands of concurrent invocations, but maybe you don't need that. So you can limit that on this end and solve the issue. If that's not good enough, right, you have, and it's a good thing, you have a lot of users, you can start thinking about dividing the load, right? And start simple with a read replica. And for example, in AWS, you can create a read replica in just one click, and even in multiple zones. So this is an easy solution. Even on-prem, you can do some kind of read replication quite easily. And then you'll have some functions that are writing information, some functions that are reading information, and the load is divided in this way, right? If that is not good enough, you can start thinking about sharding your databases, right? Which is a common practice even without serverless. And by sharding, I mean dividing your data into several instances. For example, some of the users will be in instance number 1, some of instance number 2, etc. And the function will know how to address which database according to some key. It's a common practice. And then also you divide the load on the database and can live happily with the number of connections that each database can support without being choked. So these are simple tactics that you should know and consider at the beginning, but none of them is solving the connection creation time, right? Because we can't pool in a serverless function, but we can do a different thing. We can use a static connection, meaning defining the actual connection outside of the function. And usually, for example, in AWS, the micro VM that's running your function will be around for a bit of time after the first invocation, and it will be much faster in the second time. Let me try and show that, right? Not sure about the wireless connection. I hope you can see the code, okay? This is a naive approach of putting everything in the serverless function, including a creation of the connection here. So each time the function is involved, we're creating a connection, but a minor change taking it outside, defining it here and as a static variable and creating it outside the main function can do a lot of good for you, right? Let's start it. I hope it doesn't remember my last invocation. That's a lot of time, right? I don't know if the connection of it's AWS, but we got some data back, right? It took like 7 seconds, and no connection found. That was the first invocation. It didn't use any static connection that was cached. And the second time, that's it, right? Now connection is found. Much faster. It was only 92 milliseconds. So by doing so, just by placing it outside the function, you can save tons of time. It won't last forever, but if you have frequent invocation, that will be good enough in many cases, right? So that helps with the connection time. So we had some simple tactics, and we can handle the connection issue. So we can be happy in many cases, but sometimes it's not enough. We can do some more interesting things. For example, we can put a queue in the middle, right? So basically, we again dividing the load, but with a queue. On one end, we don't have to limit the user-facing functions at all, right? It's not our limit. Of course, there's a limit, but it's not ours. And on the other end, we can decide how many connections the database can support concurrently and control it that way. But you have to remember 2 things. First of all, not all use cases are suitable for this kind of separation, right? If the user is waiting for a response, a human user, it's not a good idea to let him wait. But there are many cases that are suitable. For example, think about IoT devices that are sending a lot of traffic, metrics, measurements, and not expecting anything in response. Then it might be okay. And the other thing you need to remember is not to overflow here, right? If you have peaks from time to time, which Lambda is suitable for such scenarios, it scales very well and can help you face spikes in the traffic fast, then it's fine. But if you have a lot of traffic all the time, you might overflow the queue, and maybe Lambda is not the best option for you anyhow. So this is another option. And another interesting concept or tool you can use is proxying the connections, right? Because remember, Lambdas is not a good candidate for connection pooling in an instance, for example, but this is a way to overcome that and define a connection pool for Lambdas, right? You can have it in AWS as an RDS proxy service, or you can use in Postgres, for example, you have PG proxy or PG bouncer or PG cat, all giving you some kind of connection pool functionality. And what happens here is the proxy is maintaining the connection pool for you, right? And thus guarding the database from the wild scalabilities of Lambdas. And on the other hand, it can make everything okay on this end. Although clients might wait, but smart RDS proxy can prioritize things, for example. It can control the load. And in any case, your database won't be choked, which is the worst option, right? It's always better to let some users wait a bit before being served than to choke the database and no user will be served. So this proxy helps you accomplish that. But if you don't like connection at all, lately, well, actually a few years now, but it's still like a new concept, is ditching the connections, right? It's the question I asked at the beginning, why do we need connections at all, right? When everything else is RESTful. So newer databases, and we'll see an example in a second. So newer databases will give you REST API and ditch the connection altogether. And even relational database in AWS, for example, can have a data API. Although Mongo database, I mean, Atlas, the SaaS provider, just announced that they're eliminating the data API. I don't know why. they didn't answer me about that. But another database called Fauna database, which is a great one, by the way, not connected to it, not getting anything from them, and just love the database. They have a data API, and they define themselves as a document relational database. I don't know if you're familiar with FaunaDB. They're a document database, kind of like Mongo, but they do have transaction, and you can join different data collections with each other, which is kind of I think the main reason people are using relational database, because of the relations. And they give you a data API and ask them if there's a limit, or in a different phrasing, how did they implement it? Because I'm pretty sure that in AWS, they're still using connections in the background and just putting a REST facade in front of it. And they say that they don't have connections at all the way, and they have no limit for the number of concurrent requests. Of course, there's some limit always, but they have a great product. Just remember one thing, if you want to go in that direction, that at the end there are still machines and CPU capacity, etc. They do have a limit. So you should always monitor what's going on, right? You can't just put it there and forget about it, although it seems limitless. And apropos limitless, last week, I think, AWS published a new service or an extension for a service. They call it Limitless Aurora. And they claim that this Aurora is their serverless database offer, meaning that you don't manage the database, they do for you, and they do all the scaling. And up until now, they had some limits, and now they lifted the limit and call it Limitless Aurora. And they claim to support millions of concurrent writings, so it's worth checking that as well. Under the hood, they're doing actually the same sharding idea that I've raised here, but they do it for you. So it might be interesting, but not everyone is working with AWS and can switch there. And at the end, you're going to pay, I think, a high amount for this pleasure, because they don't have cheap offers for databases. So at least you should check it out if you're working with AWS. It might be a good solution for you, but keep an eye on the cost always. So let's take a look on Fauna. Right, they have this nice, good, you can do everything from here. This is like a test database. You have a few, I'll probably have to refresh. Oh, I'm lost the Wi-Fi connection here, just a sec. Sorry about that. I'll just mention that their API works very fast, and hopefully, unlike my laptop, so hopefully I'll be able to show it to you in a sec, if the Wi-Fi connection will be alive. But until it does, just one last option, you can always consider going NoSQL, right? And don't know how many of you know, but NoSQL is not no as a negative. It's not only SQL. So it can be very efficient, right? If you take a large JSON element and save it immediately, the whole chunk, without updating indexes, as opposed to breaking it into several tables in a relational database where you have to update the index on every table and check on traits, etc. It's going to be much lighter and faster, and you don't have the notion of connection usually. So it's simple and fast, not always suitable for any use case, of course, but if you can be eventually consistent, you can maybe trigger an RDS operation later on through a Lambda, of course, and update your relational database for queries in another system if you have to do it. So you can split and use both kinds together. Let's see if I have a connection here. No, sorry. One more time. Never mind. Just I can show you the query, for example. Although I'm here. Now I have a connection. I've cleared the cache. Let's see if it actually works. Yes, we have a connection, and we can see the data. They have a nice GUI, and we can run a simple query to get all the customers. Well, it should have been much quicker, so I guess the connection is not that good. Even in my hotel, it takes like a few milliseconds to get this response for this query. So you have to trust me or try it for yourself. As you can see, it's pretty simple. So we've covered a lot of ground. Right, we started with simple configuration change up to switching the type of database altogether, and a lot in the middle. Just one thing I want to emphasize, there's no silver bullet, right? You shouldn't run to the simplest solution or the most complicated one. You should always think and evaluate your own use case and decide what's best for you, and reevaluate it after a time, because things change. Your number of users might increase, and the load might be changing in both directions. So always monitor and always revisit stuff to make your best choice for an optimized solution. Thank you for listening. And if you have any questions, I can take them now or later on. Thank you.
So if there are any questions, if you're too shy, you can either write it out in Huva app, so he can answer that. If there are no questions, then that's it. No questions?
All clear.
One question.
Hi, my name is Miloš. I just want to thank you for this presentation, first of all. Sure. And something that I notice on this conference is that usually there is this notion of actually telling people you choose this one or choose this one. You as an architect probably know that this is not true, and you in your system probably have both in their RDS and NoSQL database, and I guess it depends on the system. My question, maybe a feedback or recommendation would be to just, all these approaches that you mentioned are of course valid, and I think we would benefit more if you would mention in which scenario, which approach would you take. That's all. Thanks.
Okay, I can answer that. Well, I think I've kind of said that along the session, and maybe I can divide it to two areas. If you can live happily with the simple solution of configuration and limiting the number of connections in your database or in your Lambda, or do some read replica, go with this approach, right? And the use cases when you have not many users, and each user is not overloading your database with complex queries, right? And you can measure that. You can either simulate or start small and check things along. If you have lots of users, then I'd start thinking about more complex solutions, either going to a NoSQL or using a data API where connections are not an issue at all, right? So I'd go simple, data API where possible, or queue in the middle, or either of these scenarios. And at the most, you'll have to go with NoSQL database, which is lighter and connectionless, and handle the joint queries in some way through Fauna or some RDS database. So again, depends on the use case.
So there are two questions from Huva. Why always notion of choosing? You can and probably should. Oh, that was yours. I'm sorry.
It's a multi-channel. Yeah.
I'm sorry. How does FaunaDB compare to DynamoDB?
How did what? Sorry.
How does FaunaDB compare to DynamoDB?
I use both of them, and I think Fauna is lighter, even cheaper. At least it was in my scenario, and light and fast, and even simpler to use, right? So I found that many of the AWS services, and it happens everywhere, after a few years, things are becoming more heavier, more complex. They have to have backward compatibility. So I like the newer and lighter database of Fauna better, and at least for my use cases. And again, I'm not working for Fauna, so I'm completely objective.
So any more questions?
Hello, Darko here. One question, you mentioned Kubernetes at one point of the presentation. What's your opinion on combining benefits of serverless with Kubernetes using virtual servers?
I think that maybe running, for example, Knative, which is a serverless framework that runs on Kubernetes, lets you enjoy both worlds. You can enjoy the fast deployments and the architectural benefits of serverless, and enjoy the scaling in Kubernetes. So this might be a solution. If you put just serverless in one side, I know, as Lambda versus Kubernetes, there are good use cases for each side. If it's more lightweight and you can build from scratch event-driven based architecture, then Lambda might be the answer for you. But if you're already working in a microservice environment and you need some features that Kubernetes can give you, like, I don't know, discovery and easily monitoring, tracing between microservices, then Kubernetes might work for you. But I think it's, in many cases, going to be more costly because you have to pay for the controller and some minimal number of nodes anyhow, even if you're not using it. And that's the strength of serverless. And it's the maintenance is more complex. So these are the trade-offs.
Thank you.
Have any new questions appeared? No? Okay, that will be it then. Thank you, Dan, for amazing presentation.
Thank you. Thank you very much.